Hi everyone, and welcome to LearnLab. In recent headlines, you've probably heard a lot about Israel's Iron Dome. It's become a symbol of modern defense, a seemingly impenetrable shield against rockets. But how does this advanced system actually work? What are its components, its capabilities, and more importantly, its limitations? Today, we're going to dive deep into the technology behind the Iron Dome, separate fact from fiction, and explore its role in the complex conflicts of the Middle East. Let's get started. So what exactly is the Iron Dome? In simple terms, it's a mobile, all-weather air defense system designed to intercept and destroy short-range rockets and artillery shells. Developed by Israeli defense companies Rafael Advanced Defense Systems and Israel Aerospace Industries, it became operational in 2011. Its primary mission is to protect civilian population centers from attacks. Unlike strategic missile defense systems that target long-range ballistic missiles, Iron Dome is a tactical system focused on threats fired from just a few kilometers to about 70 kilometers away. Let's break down how it works. The whole process, from detection to interception, happens in a matter of seconds. It's a three-part system working in perfect sync. The first part is the detection and tracking radar. This isn't just any radar. It's a sophisticated multi-mission radar, specifically the EL/M 2084 model. This radar is the eyes of the system. It continuously scans the sky for incoming threats. The moment a rocket is launched, the radar detects it, tracks its flight path, and instantly transmits this data to the second component. The second component is the brain of the operation, the Battle Management and Weapon Control Unit, or BMC. This control center processes the data from the radar at lightning speed. Its advanced software calculates the rocket's trajectory, speed, and most importantly, its predicted impact point. Here's the brilliant part. The system doesn't just shoot at everything. It determines whether the incoming rocket is heading for a populated area or a sensitive site. If it's predicted to land in an open field or the sea, the system will ignore it to conserve its expensive interceptors. This selective engagement is key to its efficiency and cost-effectiveness. If the BMC determines the rocket poses a real threat, it gives the green light to the third component, the missile firing unit. This is the part that launches the interceptor. Each launcher, often called a battery, holds 20 interceptor missiles. These missiles are the real heroes of the story. They are called Tamir interceptors. When launched, the Tamir missile doesn't just fly straight. It receives constant updates from the ground-based control center, guiding it toward the target. As it gets close, the missile's own electro-optic sensor takes over for the final phase, ensuring a precise hit. The goal isn't to hit the rocket directly, but to detonate its own warhead close enough to destroy the incoming threat mid-air, a method known as proximity detonation. This neutralizes the rocket far above the ground, minimizing damage below. And all this happens in the blink of an eye. The Tamir interceptor itself is a marvel of engineering. It's about 3 meters long, weighs around 90 kilograms, and is incredibly agile. It has small fins for maneuverability, allowing it to make sharp turns to intercept even erratically flying rockets. Each interceptor is estimated to cost anywhere from $40,000 to $100,000, which sounds like a lot, but it's a fraction of the cost of the damage a single rocket could cause in a city. This cost dynamic is a central part of the conversation around the Iron Dome, but we'll get more into that later. The system is also highly mobile. Each component, the radar, the control center, and the launchers, is mounted on trucks, allowing them to be moved and deployed quickly wherever they are needed most. A typical Iron Dome battery can protect a mid-sized city, covering an area of about 150 square kilometers. So just how effective is it? According to Israeli officials, the Iron Dome has an interception success rate of over 90% for rockets it chooses to engage. That's an impressive number and has undoubtedly saved countless lives and prevented immense damage since its deployment. It's been used extensively to counter rocket barrages from Hamas in Gaza and other groups. During major escalations, you've likely seen videos of the night sky lit up by the trails of interceptors meeting their targets. These images have cemented the Iron Dome's reputation as a game-changing defense system. If you are still watching, you must be curious about the bigger picture. We've talked about how it works, but what are its limits? And if you're new here and find this kind of deep dive interesting, consider subscribing to my channel for more content like this. Now, for the critical part of our discussion, the limitations. The Iron Dome, despite its success, is not invincible. Its biggest challenge is saturation. The system can handle multiple threats at once, but there is a limit. Adversaries like Hamas know this, so their strategy is often to overwhelm the system by firing massive barrages of rockets in a very short period. Imagine dozens or even hundreds of rockets launched simultaneously from different locations. The radar and control center have to track, prioritize, and engage each one. While it can handle a lot, a sufficiently large and coordinated barrage could potentially overwhelm a battery's ability to respond, letting some rockets slip through. This saturation tactic is central to the strategy of groups like Hamas and Hezbollah. Hamas, operating from Gaza, has a large arsenal of short-range, relatively simple rockets. While many are unguided and inaccurate, their sheer number is the primary threat. Hezbollah, based in Lebanon, presents an even greater challenge. Their arsenal is believed to be much larger and more sophisticated than Hamas's, including not just rockets, but also more precise guided missiles. A conflict with Hezbollah could involve barrages far more intense than anything the Iron Dome has faced before, testing the system to its absolute limits. Then there's the economic aspect. As we mentioned, each Tamir interceptor costs tens of thousands of dollars, while many of the rockets it shoots down are crude, homemade projectiles that cost only a few $100s to produce. This creates a significant cost asymmetry. For every expensive interceptor fired, the attacker has spent a fraction of that cost. In a prolonged conflict with thousands of rockets being fired, the financial strain of replenishing the interceptor stockpile becomes a serious concern. It's an economic war of attrition just as much as a military one. And what about a potential conflict with a state actor like Iran? This is a completely different level of threat. Iran possesses a diverse and powerful arsenal of ballistic missiles, cruise missiles, and advanced drones. These weapons fly faster, higher, and are far more accurate than the short-range rocket's Iron Dome is designed for. To counter these threats, Israel relies on a multi-layered defense system. The Iron Dome is the lowest tier. Above it, you have David's Sling, which is designed to intercept medium-range missiles and cruise missiles. And at the highest tier, there's the Arrow system, designed to intercept long-range ballistic missiles, even outside the Earth's atmosphere. So, in a scenario involving Iran, the Iron Dome would play a part in defending against any short-range rockets launched by proxies. But it wouldn't be the primary defense against Iran's own missile arsenal. The entire integrated network of David's Sling and the Arrow systems would be critical. However, even this multi-layered system could be challenged by a massive, coordinated attack involving different types of missiles and drones launched simultaneously, a strategy designed to confuse and saturate all layers of defense. Another emerging threat is the use of very short-range mortars and drones. Mortars have a very high, arcing trajectory and a short flight time, making them extremely difficult for the Iron Dome to intercept effectively. Similarly, small, low-flying drones can be difficult for the radar to detect and track. While Israel is developing new technologies to counter these specific threats, they represent a gap in the Iron Dome's current capabilities. In conclusion, the Iron Dome is an extraordinary piece of military technology. It has fundamentally changed the defensive landscape for Israel, providing a crucial shield for its citizens and proving its effectiveness time and time again with a success rate of over 90% against the threats it is designed to counter. Its ability to discriminate between real threats and those that will land harmlessly is a testament to its advanced design. However, it's essential to understand that it is not a perfect, impenetrable bubble. It has strategic and economic limitations. It can be overwhelmed by saturation attacks, a tactic that groups like Hamas and Hezbollah are actively pursuing. The cost of interception versus the cost of the rockets it shoots down creates an unsustainable economic equation in the long run. And against the more advanced and diverse threats posed by state actors like Iran, it is only one piece of a much larger, more complex defense puzzle. The story of the Iron Dome is a perfect example of the constant cat-and-mouse game of military technology, where every defensive innovation is met with new offensive strategies designed to defeat it. Thank you so much for watching. I hope this gave you a clearer understanding of how the Iron Dome works and its role in modern warfare. If you enjoyed this video, please give it a thumbs up and share it. And don't forget to subscribe and hit the notification bell so you won't miss the next video. See you next time.